In this lesson, we're going to take a look at molecules and covalent bonding. And as you can see by the cartoon we have down here, covalent bonding is the sharing of electrons between atoms. So why is it that nonmetals tend to attract electrons? Well, nonmetals tend to have an almost full valence or outer shell of electrons, such as fluorine. It has 7 electrons. It only needs 1 more to complete that outer shell and seek stability. So it's easier for them to attract 1 or 2 or 3 than to try to lose all of those multiple electrons and find homes for them. So when 2 nonmetals bond together, neither atom is strong enough. It's like a tug of war, and neither one of them can actually pull the electron away from each other, so they kind of come to a compromise and decide to share the electrons. So covalent bonding is the sharing of electrons between nonmetals. So if we take a look at the example, those 2 atoms could be the identical atom, such as the case outlined here, 2 oxygen atoms. Now what happens is they share those electrons. So this electron, this yellow one, actually belongs to this oxygen on the left, but it will spend some time orbiting around this one, and it will also spend some time orbiting around this one. So as you can see outlined here, the nucleus of each one attracts the electron to both atoms, and the electrons are shared between the 2. So when there is a covalent bond, we call this a molecule. Covalent bonds can either be single, double, or triple bonds. Single bonds implies that each atom is sharing 1 electron, so there's a total of 2 being shared in a single bond. In a double bond, there are 4 electrons being shared at the bonding point, or each atom is sharing 2, hence the name of double bond. And a triple bond, each atom is sharing 3 electrons, or there are 6 being shared total throughout that bond. Now, when you have 2 of the same atoms being bound together, we call that a diatomic molecule. Di meaning 2, atoms, 2 atoms, diatomic molecule. Now, there are some common diatomic molecules in the periodic table: hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. These are called the diatomic 7. One, because there are 7 of them, but also because if you look at the periodic table, they are in the number 7. So they're nice and easy to find, except for hydrogen, which is far over on the left-hand side. So don't forget the hydrogen when you're thinking of your diatomic 7. So how do we draw the bonds? There are a couple ways they can be drawn. A single line will represent 2 electrons. So if we have 2 hydrogens here that want to bond together, do the Lewis dot diagram, put the 2 electrons between the 2 atoms, indicating that they are being shared, or you can simplify it and draw it as a single line. Remember that each line will represent 2 electrons. So if you want to draw a double bond, you would draw 2 lines because there are 4 electrons total being shared. Don't forget when you are drawing diagrams to put in those electrons that are not involved with the bond as well. So how do we name molecular compounds? They use the Greek prefix system, and that allows us to essentially count or know based on the name how many of each atom are in the molecule. So for example, carbon dioxide, if we look here, we have 1 carbon and 2 oxygens. Carbon monoxide, you have 1 carbon and 1 oxygen. So in the prefixes, and this is on your need to know sheet from the class website, we need to know the prefixes 1 through 10. There are some examples given at the sign on how you would use those prefixes. So mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So let's use the example PCl3 for naming our molecular compounds. There are a couple steps involved. The first thing you want to do is write down the names of both elements. So phosphorus and chlorine. Those are the 2 elements that we have in this compound. You want to then replace the ending of the second element with "ide," as in here, phosphorus chloride. Now you add the prefixes to tell how many of each. So if we look at, we have 1 phosphorus. The fact that we have the name phosphorus there implies that there is 1, and you never add mono to the first element. So we just leave it as phosphorus, but we have 3 chlorides, so we say trichloride. So again, mono is never used for the first element, but if there's only 1 of the second, you do write the word mono in front. So pause the video now, take a practice on these 3 molecules and see how you do. Okay, let's see how you did. You should have had diphosphorus pentoxide, sulfur tetrafluoride, and carbon dioxide. Okay, now that we're familiar with naming, let's take a look at, so water, for example, you could call it dihydrogen monoxide. People would probably kind of laugh at you. You use the common name. So there are some where you do not follow the normal naming system. You just use their common names. There's a list of these on your need to know sheet. On a test, a quiz, or exam, you will need to use the common name. So how do we then write the formula for molecular compounds? Well, the prefixes tell us what those subscripts are, or how many atoms of each element are going to be present. So for example, if you are given sulfur dioxide, you write the capital S, you know there's one sulfur, and you know there are 2 oxygens. The di indicates the subscript, which will tell us how many atoms of oxygen are present. So sometimes, though, the name is not given. They will say something like, what would be the name of the molecule formed between this atom and that atom? Well, what do? You use what is called the combining capacity. So that is the number of covalent bonds or electrons a nonmetal needs to be stable. So you take a look at the periodic table, you see how many valence electrons the nonmetal currently has, how many does it need? Okay? So for example, carbon has 4 valence electrons. It needs 4 electrons to complete its outer shell. Therefore, it has a combining capacity of 4. Oxygen has 6 in its valence shell. Therefore, it needs 2, so its combining capacity is 2. You don't need to memorize these. Just use the trends in the periodic table to help you look them up. So for example, if we want to come up with a formula for carbon and sulfur, the first thing we want to do is write down the elements in the order that they occur left to right on the periodic table. So you write the carbon, C, and the sulfur, S. Now you write the combining capacities on top of each. So carbon needs 4 more electrons, so it has a combining capacity of 4. Sulfur needs 2 more, so you write the 2 above the letter S. You follow the crisscross rule. So you take those combining capacities and you crisscross them. You then reduce. So the 4 goes to the bottom of the S, the 2 goes to the bottom of the C. Notice that they both have a common, can be factored by 2, so it becomes CS2. Practice these 3 examples, pause the video to do so, and come back and check your answers. How'd you do? You should have had N2S3, OF2, and SiO2.